Thanks again for joining this webinar. My name is Fredrik Stolbrand, and I work as a principal analyst at Berg Insight. And today I have with me Chris, the Chief Product Officer from Emnify, and Martin Beckman, also from Berg Insight, a principal analyst as well. And we'll speak about the topic of cellular and satellite convergence. And if you have any questions during this session, please add them in the chat box and we'll answer them after the presentation. One of the key topics that I will address today is how satellite connectivity fits into the cellular IoT ecosystem and how we see this convergence between cellular and satellite technologies evolving. So when you think about the mobile and satellite communication industry today, these are quite established industries that have been around for quite some time, but they've only in recent years started to work together to strengthen the integration of the technologies used. So previously, most satellite connectivity services have been based on proprietary solutions, and they've complemented cellular terrestrial networks. But it has meant that you had to use different hardware to connect a device to a cellular network and a satellite network. So either you would use different devices for different use cases, or you had a device with an integrated cellular modem and an integrated satellite modem, which contributes to higher costs on the hardware side. But over the past years, more and more satellite industry players, they've joined the 3GPP, the standard body for cellular technologies, to work on 3GPP-based satellite technologies. And what happened in 2022 was the first inclusion of satellite networks or non-terrestrial networks in the set of 3GPP specifications in release 17, which is the latest one. And this specification that covers satellite connectivity is called 5G NTN, in which the same radio interfaces that have been developed for terrestrial communications have been adapted for use in satellite networks. So essentially, this means that you can use the same hardware for both cellular and satellite connectivity. And this integration is down at the chipset level. So the cost of adding satellite connectivity to a cellular device is very low. It's close to zero, because it's the adaptation is basically a firmware sitting on the chipset. So this is one of the key developments really on the hardware side, and there's also now a number of players on the network side investing in new satellite constellations supporting these technologies. So there are a couple of connectivity providers, satellite connectivity providers working on this. Most of these companies do not have an operational network or service yet, but there are a few that have launched or plans to launch commercial services this year. So Skylo is one of the few ones that have an operational service already today. And now in 2024, the first commercial converged connectivity services offering has been launched by emnify in partnership with Skylo. And going forward, there is a lot of work in the 3GPP to enable smoother integration and interworking of the different network components, terrestrial and satellite components, within the network. And there's also a lot of research on 6G focused on enabling seamless interworking between these different network components into a unified network. And the 5G NTN specification, it includes two different satellite technologies, which are designed for different use cases. So these are NTN and IoT NTN. And the NR version, it's based on the NR interface, radio interface, which you might be familiar with. It's the new radio interface for 5G. And the NR satellite version, it supports speeds of up to 10 megabit per second, which is comparable to LT Cat 1 approximately. And the launch of these services are not, or they're some years ahead, but target use cases are voice calls, messaging, and mobile broadband for smartphones. So really a complement to terrestrial mobile broadband services, but also satellite backhaul actually for base stations in remote locations. So that's the intended use cases. And then we have the IoT version. It's based on the LPWA technology, narrowband IoT, which is designed for small, infrequent messaging. So this is one of the first services that are becoming available now. They're based on the IoT NTN certification, and they're being launched now in 2024. And it will be used for a range of different IoT use cases. So asset tracking, remote monitoring, these types of, well, really established use cases, but also for personal safety and emergency messaging for consumer products. So you might have seen, for example, that Qualcomm's new 5G chipset for smartphones, which was launched MWC, it also supports IoT NTN connectivity. And there are also a couple of smartphones that you can buy in store that supports IoT NTN, not based on the Qualcomm chipset, but on other ones. And that also supports the IoT NTN specification for emergency messaging. We've also seen that, for example, car manufacturers are interested in this to have a complement to emergency call services, such as eCall that we have here in Europe. So IoT NTN, it will be, in our view, broadly implemented across various product categories, from simple or more like low power IoT devices to smartphones, which is really positive for the industry because it brings scale and economies of scale to satellite companies investing in this. So for IoT use cases, there are three main benefits that we see of converged connectivity services. These are coverage, converged hardware, and converged management tools. And I already covered the hardware part a bit, so I'll focus on the other ones. So when it comes to coverage, you can divide, like broadly, you can divide IoT devices into two different categories. There are fixed devices or assets and moving devices and assets. So in the case of fixed assets, there are a certain percentage that may be out of coverage, out of cellular coverage. The rest are outside. So the asset fleet of a certain company or government organization, what have you. This could be anything from, could be pipelines, wind turbines, agricultural sensors, smart meters, or other industrial type assets. And then there are moving assets that move in and out of cellular coverage. This, of course, includes all types of vehicles, but also trailers, containers or packages that are transported over long distances. And in terms of coverage, we believe that satellite connectivity will be relevant for all these types of assets, but the use cases will be different. But essentially, it will provide IoT solution providers to offer a more premium service to support customers in new geographies or when they are in need of a backup connection over satellite networks when an asset is out of cellular coverage. And on the platform side, this convergence enables unified management and control of devices connected to both cellular and satellite networks, which is, of course, it makes it easier to monitor and troubleshoot, and provides one point of integration for enterprise systems, etc. But also, it will likely also enable more affordable pricing compared to today's satellite services, as the providers of converged connectivity services, they may offer satellite messages pooled across device fleets, where some devices may require, or they'll account for more higher use of the satellite messaging compared to others, etc. So that is another aspect on the platform side. And looking at the hardware side, there are many chipsets, cellular chipsets, that support satellite connectivity now being launched. So not only for IoT, but also for smartphones that I mentioned, but I'll focus on the IoT chipsets here. So one of the things that can be good to be aware of is that there are currently two types of chipsets for IoT use cases that support the IoT NTN specification. And so there are the types of the single mode IoT NTN chipsets, like the Qualcomm 212S, and that can be used standalone in IoT devices for satellite connectivity, but it can also be added to any cellular device to support satellite connectivity whenever it's needed. And then there are these multi-mode LPWA chipsets that support LTE Cat-M, narrowband IoT, and 2G and IoT NTN connectivity. So they support this type of hybrid or converged connectivity. And you might think, like, why would you need 2G connectivity? Because it's obviously sunsetted in many markets, or becoming sunsetted now quite soon in others. But it can be very useful in, for example, in container tracking use cases, as some countries, they still lack LTE Cat-M and narrowband IoT coverage, but they have 2G coverage and will have 2G coverage for the foreseeable future. And on the right-hand side, you can see that there are many module makers that are now developing modules based on these chipsets, with some of them being available for testing. So both the chipsets and the modules, they have to go through certifications from Skylo before they become generally available. And this will likely be in the second half of this year. So we'll likely have broader availability in the coming year or so. And with that, I will hand over to Martin.
Yes, thank you, Frederick. So I'm going to talk about one of the main verticals where we see converged connectivity can add real value, and that is within transport and logistics. So IoT solutions provide greater visibility into the supply chain by providing real-time location and condition data on vehicles, such as vans and trucks, cargo carrying units such as containers, trailers, and rail cars, and also the cargo itself. And there are various hardware solutions available for each use case and each asset type and each vehicle type. And for vehicles and the cargo carrying units, the hardware is typically installed permanently on the asset and designed to last multiple years, while trackers for cargo are most often placed inside or onto the parcel. And many cargo tracking devices are also disposable and only used for the duration of the shipment. And the data that these solutions provide enables fleet operators and cargo owners to increase the utilization of their vehicles and assets, reduce inventory, identify recurring issues in the supply chain, improve customer services, reduce insurance costs, and also take actions and take immediate actions if a shipment is delayed or if the cargo is damaged or stolen. And the use of IoT solutions within transport and logistics is today widespread, but many segments are still underpenetrated, especially dry containers, rail cars, and cargo. And just to give you an idea on the addressable market size for IoT solutions in transport, you can see here the number of vehicles that are in use worldwide today. There are more than 100 million vehicles, commercial vehicles in use. The number of cargo carrying units exceeds 50 million, and the number of packages and parcels being shipped every day is more than 200 million. So it's a massive market. And we expect that the adoption of these solutions will grow heavily during the next few years as new connectivity technologies and hardware solutions are being introduced, and also as more customers realize the value of real-time data for their operations. Next slide. All right, so what role does satellite connectivity play in this market? Well, satellite connectivity adds an extra layer of resilience and redundancy to supply chain operations. The vast majority of real-time tracking solutions used within the logistics industry today are based on cellular technology. But when transporting goods through areas outside of cellular coverage, location and condition data is not transmitted and can't be accessed from remote. Adding satellite connectivity enables close to real-time data transfer, even in remote locations. And satellites also provides a backup connection, which kicks in if the cellular network is not working for some reason. Fleet operators and shippers can therefore trust that if a deviation occurs in terms of route or temperature variations or whatever, they will get notified about this instantly, regardless of if the shipment or the vehicle or the cargo is within cellular coverage or not. And this may be critical because a delayed notification will lead to delayed actions on how to handle the cargo or how to handle the deviation, which may cause even greater problems down the supply chain. And satellite also provides true visibility of assets in the field, assets such as trailers and containers. When these assets are not in actual use, when they are transporting goods, they are typically parked at a trailer yard or container terminal. And these sites may be in remote locations without a stable and reliable cellular connection. There's therefore a big risk that these assets are lost or that carriers have to spend a lot of time just to go look for their trailer in the yard. And there are three main product groups where uninterrupted and reliable connectivity is even more critical. Goods transported in the cold chain, for example, foods, vaccines, pharmaceuticals, they are typically very sensitive to variations in temperature, in humidity, sensitive to vibrations and light as well. So for example, if the temperature goes above a certain level inside the trailer or container and no action is taken, there is a big risk that the cargo is damaged or spoiled when it arrives at the end destination. And similarly, for high value goods, such as electronics, vehicles, and pharmaceuticals, it is vital to immediately get information about any route or temperature deviations, because some cargo loads could be worth millions of dollars. And if something happens with the shipment, you definitely want to know that you know about that instantly, so you can take actions accordingly and potentially save the cargo. And the third category, it could be a manufacturing company waiting for a key component or a part. Maybe the component is not of high value, but it's very vital for their operations. For them, it's critical to know where the shipment is, where their cargo is, just to plan their operations, and in turn to provide better information about it to their customers. So in sum, satellite connectivity is a complement to terrestrial networks, which is extra valuable for long-haul transports through remote areas and when transporting critical and sensitive and high-value goods. And next slide, yeah. We also want to highlight one of the key trends that we see in the logistics IT segment, which is the advent of smart labels. And we believe this could be a game changer for the logistics industry. So smart labels are shipping labels that contain environmental sensors and a cellular modem, which enables for real-time location and condition tracking of packages, parcels, and even small envelopes. So these tracking devices are so thin and lightweight that they can easily be attached to any package or parcel. And several technology companies are currently developing or trialing smart label solutions. Some solutions are already in commercial use. And the addressable market here is massive. As mentioned previously, hundreds of millions of packages are being shipped every day across the world. And up until recently, trackers for cargo have, in many cases, been too big or too expensive for many use cases. But with smart labels, this is changing. And the price per smart label is expected to decrease heavily going forward as the cost for components and sensors decrease, and also as smart label companies benefits from economies of scale, because many of these companies are startups with limited resources, and they are still in the early stages. But we expect that the demand for and the use of these solutions will grow exponentially in the next few years.
Okay, now we'll have Chris from emnify speaking.
Thanks a lot, Frederick. Thanks a lot, Martin. Hi, everyone. Warm welcome from my end. Super happy to be here. Yes, Frederick already told you my name is Chris Rüttges. I am the Chief Product Officer at emnify. So I am responsible for everything around product and portfolio, as well as our network access partnerships with operators across the globe as one of our key differentiators also. I'd like to talk about two things today. I'd like to briefly introduce you to emnify and our IoT super network. And obviously then we'll be happy to deep dive a bit more around our satellite converged offering, which we have been commercially launching. And with that, please move to the next slide. So just briefly on emnify. So what are we doing? emnify is a software company. We are building and providing software-defined cloud-native IoT connectivity. We're serving a couple of thousand customers worldwide, double-digit number of SIM cards under management on our technology. And the company has been founded actually 10 years ago. So we just celebrated our 10 years anniversary a couple of weeks ago. And it was founded around the vision to do things in a way that customers actually want to have them and not in the way, let's call it the traditional player, we're able to provide it. So we've been turning some principles upwards down. So what does that mean? I'll give you 3 examples. The one is, obviously the whole company is, with regards to people, technology, value proposition, is 100% IoT dedicated. So IoT is not a side product as it might be in other companies. It is our DNA and our bread and butter in everything we do. And obviously full focus on that. Secondly, it is truly global. So the whole technology has been designed from a global perspective, knowing that all of our customers have multinational, international, and global needs. And we're not acting out of a local home market into the world, but the whole thing has been designed and deployed globally. And the third and very important element is we are defined around a cloud native mindset. So the whole technology is cloud native, bringing all the flexibility and scalability of that way of doing things. And obviously, secondly, a superior consumability and customer experience with regards to the old ways of doing things. The result of that is what we call the IoT super network. And I'd like to give you some more insights into that. If we please move to the next slide. So the super networks consisting out of 5 key pillars. The first one, been mentioned, that is the global and obviously IoT dedicated network we have been building. It is globally distributed as a mobile core network. It brings obviously a global feature consistency across the globe, the same quality of service, the same feature sets, wherever the customers are based and obviously deploying their devices. That means we're live in 7 core regions, 26 local breakouts. And we have been obviously following our customers and deploying our services there where they actually need to have it. We have a single SIM with a multi-IMSI technology, combining over 500 network partners, which mainly direct agreements. One of our strategic decisions to go for direct IoT-specific roaming agreements, knowing that customers need reliability of network access as well as feature across the globe. And obviously, we're supporting all 3 GPP bearers. And also now the satellite, as Frederick has been mentioning, become a joint of the 3 GPP family, and obviously something we are also doing. Cloud native, already mentioned that, a very important pillar of it, particularly around the consumability. We know that most of our customers nowadays build their IoT solution and application on the public cloud. So they're expected to a certain way of consuming technology. And this has been from the beginning part of the architecture of how we do it. And that obviously means that IoT connectivity for us is also some kind of cloud resource, meaning it is instantly available. It's just a click or an API call away. And obviously it is fully designed to be self-serviced and self-served for customers. Only remaining physical element we have is the SIM still, but we're working on this one also to potentially in some time get rid of it and be a fully software service. The third pillar, we know that a lot of our customers obviously developing their application, and we will help them, or we are helping them. And we actually have a lot of integration into services to speed up their work. That means data streams in all the public clouds, AWS, Google, as well as integration into our customer processes, for example, with no-code workflows based on Zapier, into Slack, Salesforce, and Google Sheets and other examples, with obviously the ultimate objective to help them in building the application faster, deploying their services quicker, which also is something which helps us to grow with them. The fourth pillar is around real-time network insights and obviously transparency. We're providing the full technology stack, meaning the mobile core network, the connectivity management platform with a portal or an API, and we are exposing all data of our customers to them based on our data streamer, for example. This includes all network events, location updates, PDP context, red types, EMIs, all usage data, and all policy events. So whenever there's a threshold which is reached or a limit set or SIM status, that's something which is actually in real time streamed into our customer's application based upon our data streamer. And last but not least, security is something we are taking very seriously, enabling our customers across the value chain to have the maximum security from the SIM up to their application. That starts obviously with the secure UICC. It continues with network firewalls, VPN, IPsec, email logs up to the portal we are actually providing to the customers. So bottom line, this is our super network. It is 100% controlled in the sense that it is in-house built. We're not depending on any vendors or any license fees. So we are in control of the technology and we are in control of the roadmap. And that has been also proving very helpful in being the first in launching a satellite proposition. Because obviously, whenever we decide to take something seriously, we can do it directly since there's no dependency to a third party. And with that, let's please have a look at satellite and the next slide, please. Yeah, so Frederick has been mentioning that we have been commercially launching the satellite. We actually started this journey at MWC in Las Vegas in 2023, announcing it with our partner Skylo. We then engaged with a lot of customers in an evaluation program. Over 20 customers have been accepted. We needed, unfortunately, to limit it due to capacity. From our end, we had a huge request for that, which was great. So we are now engaged with 20 customers of all kind of industries, together with Skylo, obviously, as our partner on the satellite, and Murata on the device or the module and the evaluation kit side. And we obviously took this feedback and the learnings into account. And the key benefits which we actually cleared and defined during this evaluation program is that this new converged solution actually provides a completely different experience than the use of satellite did before. It creates a different experience for our customers in the sense that everything is converged and seamless now. It's one SIM, it is one technology stack, it's one portal, it's one API, one invoice. So everything is converged, and that brings a completely different usability, obviously. And it secondly provides also a different user experience and a different customer experience for our customers' customers. It is a real upgrade to, for example, a tracking solution, as we discussed earlier, because it obviously now brings a completely different reliability and experience of the service to the customers of our customers. And it's one of the rare moments where you're not only changing a technology, but you can really up-level your product to something new. And that's super exciting. And with that, obviously, Frederick has been mentioning the key benefits also. It's a clear minimizing of the hardware spends. It reduces massively the complexity of building a solution and operating a solution. And we obviously also are now able to provide flexible data plans by combining both technologies, which makes it much more accessible from a technical as well as commercial perspective to our customers. And with that, let's have a look on our commercial offerings, please, on the next slide. So as I said, in the EVA program, we've been listening a lot to you and our customers. Frederick has been pointing out that there are two generic needs for satellite and actually pain points we can solve with that. The first one is that I, as an application provider, I definitely need some kind of heartbeat guaranteed and reliable for my asset whenever it's in the field, independently if there's a white spot on cellular or not. And the second one is that obviously some of our application partners are deploying stationary devices in regions where ultimately there's no cellular coverage or bad coverage. They normally don't know that before they start, so they need this kind of ease in mind in having a solution which can work either on cellular or on satellite if that's necessary. But now let's focus on our heartbeat proposition. So it's, as I said, it's super important that you have this ease of mind of getting an information of your device here and there, which we've been translating into satellite messages combined with a cellular data plan per SIM per month. There are 3 flavors to it, depending on our customers' use case and also the frequency of messages they want to have, in the sense that there's a 10, a 30, and a 60 messages plan per month. This all comes, obviously, as I said, with a cellular data plan, and it is pooled across our customer SIMs, making it much more efficient, obviously not worrying about thresholds and managing each device, but having also an ease of mind that you can share across your fleet the service we're providing. And with that, next slide, please. So as I already mentioned that in the EVA program, we have been engaging with all kinds of customers across all different industries. On this slide, you see a summary of the key industries where this is super relevant. In the end, it comes down to what I already mentioned, that there either you have an asset which is super valuable, or you need to be sure for legal or regulational situation that you are able to provide a heartbeat. That's mainly in the asset tracking and monitoring vertical the case. In other cases, it's mainly about being able to deploy devices and mixed fleets, I would say, in all over the world, and being sure that you always have connectivity service wherever you provide your service, being it in remote operations, in agriculture, or environmental monitoring. Yeah, so long story short, the ease of use, the consumability of the service, the experience, and also the fact that we are now able to bring cellular and satellite technical and commercially together opens up a completely new customer group. It becomes much more accessible and hence relevant for a lot of IoT customers. And that's what we've seen confirmed in the engagements we are doing already with our customers. So we're really convinced that this is the right step to go, and that there's a relevant market out there where we are obviously solving problems which haven't been solved before. And with that, I'd just like to thank you and looking forward to your question.
Yes, thank you, Chris, and thanks everyone for listening in. We do have a couple of questions, and if you have more questions, feel free to add them in the chat box. I will start to read out the first couple of questions that we have. So the first one is, do the device need to have access to a sky view or clear line of sight, as it's sometimes called? I can start by addressing this question, or do you want to go ahead, Chris? Or
I mean, I think the answer is yes. This needs to be in line of sight of the satellite, obviously. So if you're in the cellar somewhere, it's probably not the best position for deployment. But Frederick, happy to have you amending on that one.
Right. So I think there are some similarities with GNSS positioning here, because it uses similar frequency bands, and with GNSS you don't necessarily need line of sight. I mean, you could have an OBD port or OBD2 device in a vehicle, for example, and it will work. But it's obviously more sensitive to the wireless performance is more sensitive. So I guess it will depend a lot on the design of the device and the antenna, but Chris has more practical experience of this, so I think we'll listen to him. And the second question is, what is the latency?
I think that highly depends obviously on the satellite partner you're picking, and it obviously depends also if there's a GEO or LEO technology behind. With our proposition, I can only say it is obviously not a latency which you have in a cellular network. So it is more towards a second, I would say, than towards milliseconds.
And the next question is it possible to get more than 60 satellite messages per month?
But yes, it is. We've been obviously defining those packages not out of the blue, but because we see certain usage patterns in our customer base. But if there is a need for more messages, then that's definitely something we would be happy to discuss.
There is a second part to this question, and that is, what is the biggest packet size that can be transmitted?
The biggest, well, the service is defined as a message, and with satellite, we are obviously, we cannot compare the bandwidth we are having on satellite than we have on a cellular network. And a message is 100 bytes on a satellite.
Yeah.
So it is a heartbeat. It is not probably something you would use for dashcam streaming or anything else, right? That's not what the service is about.
Right. And we have a question, another question about emnify. Does emnify have business operations or services in Canada?
Well, as I said, our service is globally. So the super network is available globally. We have a global SIM, which also provides services in Canada. So yes. With regards to satellite, we have to say Skylo is not yet fully globally available. And that's something which we obviously reflect in the offer. So far, it's launched in Europe and the United States. And we're in discussions around extending the service into further regions of the world, depending on also the demand we are getting from customers.
Let's see, there's another one about latency. Am I right to understand that end-to-end latency is seconds?
I would say it's more a second. It's more a second than 80 milliseconds. But it's very difficult to tell and give a clear, right? It depends on the application. So there are multiple factors, but generally speaking, there's more latency than the cellular world today. Yes.
Right. I think it should be mentioned as well that these satellite services are based on narrowband IoT, and even terrestrial narrowband IoT networks, they have latency in the seconds, and that's what it's designed for. So for satellites, it will come up a little bit, likely, but it will be in the seconds. How is the availability of the network depending on the number of satellites and their orbit? Right, so this one is about coverage for the satellite service. I can just speak generally. Of course, the coverage will be dependent on the satellite constellation and if they're geostationary or if they're LEO, and it will depend on the number of the number of satellites in the constellation. That is a very general answer, but yeah. And in what countries or regions is this available? Isn't that the
So
question?
as I mentioned, the commercial availability is for Europe and the United States so far. That's what we've been announcing, and there are more regions to come. Yes, period.
Right.
But if you, and as I said, it is a discussion we're constantly having with Skylo on how to further roll out new regions from a satellite perspective. If there's a need for other regions, then we are happy to engage and to discuss. It is obviously something we will take seriously and look at. So please feel free to reach out after the webinar and we go from there.
Right. There was a question as well about the test, like how can one test the emnify converged product offering?
Well, you can either reach out to me after the webinar, or you can go onto our website. I don't have the full link on top of my mind, but as I said, yeah, you can reach out to us on the website, and then we can help you with a test kit. Absolutely.
Right. And for pricing, participants they should also contact you, Chris, I would assume.
Yes, please.
Does emnify have a partner program?
Well, we have partners. So if that's what we call a partner program, there's no official program in the sense of an application form. But if there's interest in partnership, as we do it with hardware partners, as we do it with Skylo, for example, then also reach out to me and we go from there.
Yep, sounds good. We'll go through a couple of more questions. We have a couple of more minutes left. What protocol are you using, UDP or NIDD?
It is UDP.
Right. In which country is emnify a licensed connectivity service provider? Does the super network meet all the regulatory data sovereignty requirements worldwide?
That is a big question. So it generally does, obviously. As I said, we are acting globally. We are working on a 901 IMSI, which is a global resource, transparently and dedicated for IoT. And obviously, we're covering that back to back with our local network access partners. Yes. And we're obviously complying to the local data and regulatory rules where relevant. And that is a market per market discussion we're having. One example I can give, we just recently, or actually mid of last year, we launched our Brazilian operations, knowing that the Brazilian market is somewhat different than other markets. We are a full licensed MVNO in Brazil with our own IMSI. We have an agreement with the local MNO, and we are obviously fully compliant to local legislation and regulation. And we do that for other markets if necessary and relevant from a demand perspective.
Right. So I would believe we're on the top of the hour. And finally, where can people get in touch with you, Chris? What's the best way to contact you?
You can drop me an email. I'm not sure if we shared the emails in the webinar, but I guess we have yes, we can do that. I will figure out that with our staff on how we do that.
Right.
And you can always go to our website and open a request referring to that webinar, and we can go from there.
Perfect. And feel free to add me on LinkedIn or send me an email if you want to reach out to me.
Same for me. Thank you.
Yeah, me too.
Perfect. Okay. Thank you, everyone. We really appreciate your time. So you will have that in your inbox in the next couple of days or next week.